Good evening, students. I'll start with the class. So today we'll start with a new chapter. That is motion in a straight line. Okay, so any object, okay, will be either at rest or it is said to be motion. Means it is moving. Okay, whenever there is a movement of any object from one place to another, will be called as a motion from one place to another. The object could be two ways. One is it could be at rest. Suppose when it is called as rest, when the object does not change its position with respect to its surroundings. This is called as with respect to its surroundings. You don't have to by heart, huh? With the with passage of time. And suppose if you wait for 1 hour looking at that object and that 1 hour has passed. Passage means passing of the time. You keep watching it and it has not changed its position with respect to its surrounding for 1 hour, then you can say the object was at rest for 1 hour. And then motion will be if it changes. Object changes its position with respect to surroundings. Everything will rest remain the same with respect to its surrounding with the passage of time. So if the position has changed from one to another, that means the object was in motion for that particular time or within that passage of time. So these are the words which you will normally come across: rest and motion. So this chapter is all about something called as kinematics. Kinematics is nothing but the word kinematics means means movement or motion in Greek word. The Greek word. And matics means mathematics. So it's like study of or calculations of the motion or the movement. Okay, this would mean math. So these are simple things in words, meaning it means. Now, from actual this what you need from chapter point of view. From here, it's very important to know the concepts. Difference between distance. So you'll come across this word distance and displacement. This side, if it is distance, we will keep displacement this side. Okay. Now, I'll just give you an example first. I want to go from A to B, suppose here. How many ways can I go? I can go in infinite number of ways. One, suppose I choose this path. I may choose another path. I may go roam somewhere and then come back. Sometimes I may go this side, come back. Sometimes something. So I have many options to go from A to B. So consider if this is path 1, this is path 2, this is path 3. Okay. So 4 people suppose have traveled from one place to from point A to point B in their own ways. Now, what is distance? Distance is nothing but the path. This is the path. Path means the way which the person has taken. So this is path 1, this is path 2, this is path 3 and path 4. So distance means how much ever he has taken, okay, the path length from to reach from A to B. So this is distance. And what is displacement is nothing but the shortest distance. The shortest distance from A to B. We don't care how much from where he has traveled. We want that distance which could be the shortest, the shortcut from A to B. So as per that, can anyone tell me which path will be the shortest? The fourth one.
First one.
Fourth one.
Fourth looks this.
First one.
First, no?
First
Straight
one.
line. Yeah, if
First one.
measure this, yes, obviously. Because any straight line will definitely be the shortest. If you there's a road, see, suppose. Okay, from your house to one stop. Imagine you're going from the field somewhere and taking rounds like this, and then going back. Definitely, this will take more time. See, by the time you are coming here, you would reach here. By the time you are reaching here, again taking a round, you would have finished also. So looking at this, the straight line. Okay, or you can say this is the shortest distance. So displacement is nothing but the shortest distance between the initial point and the final point. And this is simply the length covered from initial point to final point. Okay, so distance would be all this. All 4 are distances. Now, if I want to specifically know what is displacement, then I have to go for shortest. Otherwise, all 1, 2, 3, 4 are all distances traveled from A to B. So in a given time, you can. Now, the second thing what you should know is it's a scalar quantity. I'll explain this with the example also. So over here, if you have drawn the diagram, you can just randomly draw a diagram, and this would be path 1. These are all the paths. Path 1, 2, 3, 4. These are all the distances covered. And if you want to know only displacement, then specifically path 1 was the displacement. Now this is a scalar quantity, this is a vector quantity. Now scalar means only magnitude is required. Magnitude means the value, how much distance or whatever it may be, will be only in terms of magnitude. But vector will need magnitude and direction. So that's why it is called vector. Scalar needs only the magnitude. Example, a car covered distance of car covered, yeah, distance only will say, a car covered distance at 60 km per hour. So we know that that car moved 60 km in 1 hour. He traveled 60 kilometers in 1 hour. Now here, car covered or 60 on I'll keep towards east, suppose, or north side or west, whichever it may be, upward direction, down. Okay, I say a car covered distance at 60 kilometers towards east. Now I'm specifying the direction. Okay, so in displacement, we definitely need directions also, from where to where we have traveled, because we want to know finally where the final point comes. Initial point and final point, we need to know the shortest distance. Whether we have gone east, whether we have gone west, we have to know. So in displacement, remember, we need to know the magnitude as well as the direction. So that's why it is called as a vector quantity. Now, just consider this. Suppose A, this is B. I am traveling from here to here. I have suppose 10 kilometers I have traveled. Okay, I went from here to here, and then again I came back home. Can anyone tell me what is the distance I covered?
20 kilometers.
Yes, distance would be 20 kilometers. Can anyone tell me what would be the displacement? It's like the difference between the first and the final point where I reach back. How will it be 10? You see, the shortest distance. Yes, displacement is 0. Why? I was standing here. I went everywhere. I took a turn and I came back. I'm back to the same point. So it's like A minus A only. I'm back to the same point. So I've not changed any, no matter where it is. So this was my initial point. Okay, I started here. Wherever I went, doesn't matter. Again, where I came, my final point is also back here. So with reference, this path is all gone. I have to just look at where is my initial point and where is my final point. I'm back here only. Is there, looking at the dot itself, there is no displacement only, there is no shift only in me that way. Distance covered is definitely 20 kilometers, but displacement is nothing but between the initial and final. So displacement is 0 because I'm back to the same point. So that's why the direction also matters here in this case, because if 20 kilometers, I could be simply going from A to B also 20. In this case, I don't need which side I am going. I could only tell my distance covered is 20. But for displacement, I should know where is my final point. So which direction I'm traveling also matters here. Then displacement can be either positive or negative. Based on the direction, it could be positive or negative. And here, this has to be only positive. Can be 0 also. Just now what we checked. Positive, it could be negative. When once we start solving the problems, we'll understand. Some places we will get displacement as positive, somewhere negative, but distance is always positive because you're measuring the length. Here you're measuring the difference between the first and the last point. Okay, so this is the difference which you should be knowing. Any doubts in distance and displacement? Just remember only this. For displacement, it is the shortest distance, or it's nothing but the difference between the initial and the final point. Distance is actual what you are covering. No matter where you are going, everything has to be followed. So remember, you can write it as a note. Distance is always greater than equal to displacement. Distance traveled will always be more than the displacement, or it could be equal also. If it's a straight line, no, distance and displacement is same. But if you are covering like this, what is going to happen? Your distance is more and your displacement is less. So distance can be either equal or more than your displacement. Path 1 is definitely your displacement because that's the shortest one. And no matter where you go, okay, this distance, if you see, compare, it is always more than your displacement or equal to, because even 1 is a distance, no? So in that case, distance will be equal to displacement in path 1. In path 2, distance is more than displacement. Even in path 3, distance is more than your displacement. So note, distance should always be greater than equal to displacement. Then in the starting of the page, no, this is not actually important, but still I will tell you something. You will come to know, come across something called as one-dimensional motion, two-dimensional motion, three-dimensional motion. So just motion in one dimension, two, or what does it mean is 3 dimension means always, till now whenever we were plotting graph, no, we always came across like this, x-axis and y-axis. But in 3 dimension you will have 3 axes, that is your x-axis, y-axis and your z-axis. X always to be written here, huh? Y here and z here. Now you consider any point in space. Okay, how we had any point, just x and y coordinates. Now while plotting the graph, you always have x and y. Now in 3 dimension you would have x, y and z. So any point. So P of x, y, z. So these are called as a coordinates. Now this point means this. Suppose if this point is moving somewhere in the space. Okay, consider there's a point P is in motion. So only if its x coordinate is changing, means it is only moving only in one direction, like straight line, no? Okay, so this is called as one dimension. Just a plain straight line if it is moving. So only if only one coordinate changes, then it is called one dimension. Or in theoretical terms, suppose if you want to know in terms of definition, only one coordinate is needed okay, to specify the position. This actually is a difficult to understand, but that's why I've given this. Both I will give. If only one coordinate is needed to specify the position of the point, then it is called one dimension. It means what is, if only x is enough, okay, like in one direction, only my x coordinate is enough. This is the distance x it has traveled. Only this much if I need, then it means it is one dimension. If I need both, suppose if it is traveling this side also and then this side also, so if two coordinates are needed in x-axis as well as y-axis, suppose if it is moving that point, then it is called two dimension. Same thing, okay, if two coordinates are needed to specify the position of the point, it will be called two dimension. No one will ask this for exam. Just now because it's there on the textbook, you all might think I have not done it. I'm just giving you that. And then the 3 dimension will be three coordinates are needed. It's like the point is moving in space in any direction, not only in whether straight line or this. So it could be anywhere like that. So all the 3 coordinates will be needed to specify where the point is moving. So in that case, it is called 3 dimension. Like if you have a flying aeroplane and all. So definitely the aeroplane is moving in space. So we will need all the three coordinates. Here this will be like if you are walking on a straight line, if you are walking on a railway track. No, this is extremely important. Difference between speed and velocity. Same way how we had distance and displacement, no? This is similar. This speed is always a scalar quantity. And this fellow is a vector quantity. So now you'll actually understand what is the difference between speed and velocity. In first chapter, we were taking it same, no? Dimension wise, it will be same, huh? It will not change. That MLT and all for speed and velocity is same. But what exactly it means, we will study now in detail in this chapter. So even this one will need only magnitude, and this needs magnitude and direction. So the formula here is speed is nothing but distance upon time. And definitely vector means here it will be what? Velocity is nothing but displacement upon time. And now you know what is the difference between distance and displacement. Nothing but this fellow is the shortest distance. This is the actual whichever distance it must have covered. So I'll give you the example. Okay, from here to here, if the person has traveled 10 kilometers. And now again he comes back. Okay, and then again 10 kilometers. This is done in total 1 hour, and coming back is 1 hour. While going, he traveled 10 kilometers in 1 hour, and then again he came back for 10 kilometers in another. So what will be the speed? Can anyone tell me? What will be the distance covered from A and back to A? How much will be the distance total covered? Yeah.
20 kilometers per hour.
And how many hours? Total time you have to take. 2 hours. Yes, so that will be 2. So here 10 he has traveled in short 10 kilometers per hour. Now displacement will be different. This will be 10 and then coming back. So 10 minus 10 only because it's in the opposite direction. See, so it's like coming back to the same position. Time anyways will remain the same in 2 hours. That will be 0 upon 2, which would be 0. So velocity will be 0. So that's the difference between speed and velocity. So you have to be careful. Speed means distance upon time, and velocity means displacement upon time. The next word you will come across is average speed. Same way we will have average velocity. So it's nothing but total distance upon total time. Same way over here it will be total displacement upon total time. Now consider you start from one place, you start from Cape, okay, then you go Margam, and then you go Verna, suppose, and then you go from Verna to Penji. Now from here to here you were traveling suppose at 40. Okay, we have different speeds now. You took suppose on this 40 kilometers per hour. Here you must have taken maybe 50 kilometers, and here maybe like suppose 60 kilometers. Here you must have taken some time, 1 hour. Here you must have taken 2 hours maybe. Here again maybe 1 hour. So what is the average speed is nothing but like the total distance. So here you want to calculate, for example I'll show you. My average speed would be going from here to here, the total distance. Or you can say only kilometers I'll give you. So from here to here you must have traveled suppose 40 kilometers. Now randomly, don't go to measure how much distance is there. It will be less definitely. You must have taken long cuts and all and something like this. So total distance would be 40 plus 50 plus 60. And then this would be 1 hour plus 2 hours plus 1 more hour. So it's like calculate adding all the distances and all the time. And then you have to calculate it. So this would be 150 upon 4 kilometers per hour. So this is how you have to calculate a average speed. Nothing but the total distance covered upon time. Here in this case the displacement also will be same, because here right now we are just showing one particular direction, so assuming that that's the shortest one. Okay, if it was something else, if you were coming back from Verna back to Capen, then it would have been different. Anyway, we'll be solving more problems on that with displacement also. But as of now, just try to understand what is nothing but total distance upon time is always called as average. And now what is instantaneous speed you will come across. This word means exactly at one particular point of time. Or exactly at that instant of time. So suppose if you had left here at 2 o'clock and I want to know what exactly was my this speed at 2:30. Okay, so exactly at 2:30 what was my speed? Because definitely when I'm saying I'm traveling 40 kilometers per hour, when you try to calculate, imagine you were traveling by bike. So whole time you must not be this exactly at 40 speed on your bike. You must have gone at 20, you must have gone at 30 because of traffic or some reason. So suppose if I want to know exactly at 9:30 what was the speed on the bike which was showing it, so that would be called as instantaneous speed. And whenever we talk in terms of general, this is like how much 40 kilometers you traveled in an hour is always like the total in short, like on an average basis we tell. But instantaneous means exactly at that particular minute or that particular second, what exactly speed is showing on your bike. So that would be like a instantaneous speed. So exactly at one particular point of time, not the whole distance. Now we will solve some problems based on this. So any doubts will all get cleared over here. A boy walked 3 meters towards east in 2 seconds. Then 2 meters towards west in 3 seconds. Find the average speed and average velocity. Okay, read the question. No, you just try to frame this. He started over here, suppose. Now he came here. He traveled 3 meters. In how many? So the total distance covered is 3 meters in 2 seconds. It took time, how much it took? 2 seconds. Now this is east side he went. Then he came back to 2 meters. This is the final point C, suppose. In how many seconds? From here to here he took 3 seconds. So this is the diagram. Now let us calculate what is the speed. Speed will be nothing but, as per the formula, total distance upon total time. So it would be directly all the distance what has he covered, the path length starting from A to B and then to C. So how much it will be? This is 3 meters. How much will be the total distance here? How much has a person traveled? How much distance?
5 meters.
Yes, 5.
5 meters.
5. 3 meters plus 2 meters. So you can just write it as 3 plus 2. And total time will be 2 plus 2 seconds. and from here to here it would be 3 seconds. Then it's 5 upon 5. This is meters and this is second. So 1 meter per second. So that's the speed. Now, let us calculate the velocity. Total displacement. Time you can never minus, huh? Time always to be added. So can anyone tell me what will be the displacement? What is the difference between A and C?
1 meter.
Yes, 1 meter now. So the displacement here is 1 meter. How do we get? It's like this is going in the positive direction, so I'll take it as plus 3. Coming back, 3 minus 2. Okay, so this is the difference from 3 and then back to 2. Total time is anyways added on. So 1 by 5 meter per second. So which will be 0.2. So this is the difference between speed and velocity. Anyone who has not understood how to calculate total displacement, it's like if it's going in the opposite direction, then it would be minus. So it's like the shortest distance between A and C. So C would be here. Now just to show you the difference, I've drawn the line down. It's like coming back on the same line. Okay, and then here it would be the final point. So it would be 3 and minus 2, that would give you 1. Next question. A man goes from A to B at v1 speed and returns from B to A at v2 speed. Derive average velocity and average speed. So we'll be deriving like a general formula also here. I'm trying to understand also what is the difference between velocity and speed. Is going from A to B. Now speed is given, nothing else you know. How much distance covered, nothing we know. This is v1. And it comes back in the same direction, then v2. And draw like this here, back B to A at v2. So whenever only this much has been given, you have to assume that let the distance be from A to B, D. Any distance you can take. So I'll use the letter D. So from here to here you mark D. And let time t1 while going. So not necessary while coming back also you may take the same time. You can assume a different time while coming back. The time taken from B to A, B, T2. While going you might take 1 hour, while coming back you might take 2 hours. So we have to take different time. Distance definitely remains the same. That will not change. A to B and B to A will be same. You are following the same path. Okay, so the time taken from A to B will be T1 and the time taken from B to A, T2. Now what will be the average velocity? Can anyone tell me? What is the answer for average velocity? Just randomly tell me. What will be average velocity formula? Displacement upon time. Total displacement upon total time. So what is the displacement?
Zero.
Yes, it will be 0 because you know that it returns from B to A, so it's back to the same point. So it's like beam and then coming back also same distance d upon time. So anyway, 0 upon anything will be given 0. So average velocity is anyway 0. Now we'll calculate average speed. So average speed is nothing but total distance upon this formula I have to know. Total distance will be how much? From here to here I'm going d and then coming back upon total time. Okay, this is in terms of normal formula. Now, if you look into the question, okay, t is not given to you. Time is not at all given to you. Now, how will you calculate then? Definitely, you don't know what is time. So, if I had to calculate average speed and I'm putting in the formula as t1 and t2, if v1 was given to me as some 10 and this was given to me as 20, where would I substitute here to check? I would be lost. Okay, so what we'll do is we'll try to write this formula in terms of v, in terms of velocity, so that any time in the question if velocity is given to me, I know how to find the speed, because time is definitely not given. So we'll not know what substitute for t1 and t2. So we'll try to write it in terms of v. So we'll remove out this t. How to do that? You know that speed is nothing but distance upon time. So what is time? If you take this up, this fellow will come down. So time is nothing but distance upon speed. Anyone who has not understood this? It's like cross multiplying. Time will go up, speed will come down. Okay, so what is the relation? How we can, time is nothing but distance upon speed. So let us check over here. So what will be T1? T1 will be nothing but what is the distance covered? D. And what is the speed? V1 as per this. You can write here also, no problem. Huh? So time is nothing but distance upon speed. How we got? The normal formula, we know that speed is distance upon time. So time, I just want to know what is T1. So T1 is nothing but how much distance it has covered. So that is T D upon T. Same way, what will be T2? The distance will be anyways D only because back the same path and then at speed V2. So what you do? Put these values of T1 and T2 in this equation. In equation 1 you put, instead of T1 you substitute this, instead of T2 you substitute this. Why am I doing this? I want my answer in terms of V. I don't want in terms of T because time is not given in the question. So what is this? Average speed. I'll write it again. So this anyways will give me 2D. So instead of T1, D upon V1, and instead of T2, I'll put D upon V2. So now T is gone. Now what is common between the two terms? D is common. So just take out D common. So what will remain? 1 upon V1 plus 1 upon V2. And what is going to happen? D and D will cancel. So if you notice, everything is only in terms of V now. Now calculate. So you cross multiply this. This will be V2 plus V1 and then this. A upon B upon C I have taught you. This will become ulta. So this V1, V2 will go up. Whether you write V2 plus V1 or V1 plus V2, it means the same. So average velocity is you can also remember it as a formula. This is a shortcut method. If velocities are given, no, average velocity is directly, you can do this shortcut formula. Otherwise, you have to follow the long method. This no can be used for MCQs, objective type questions. You don't have to do all this and then convert and then calculate. You can remember is directly. Where it will be used, now you'll understand. I'll give you a problem now in terms of pure numbers. Now suppose if the question is a man goes from A to B at 40 km per hour and B to A at 60 km per hour. Calculate average velocity and average speed. This is B to A. So now like this type question comes, then what to do? So the derivation, if you have understood, it will help you here. Now it depends on the marks, okay? For exam, if it's just 1 mark question, no, you can directly use this. With the MCQ, no, objective just tick mark. this, then you can directly use the formula. But if it's a problem of 2 marks or 3 marks and all like that, then you have to follow the long method only. Otherwise they will cut marks, because this is like shortcut method. You can confirm your answer by using this formula. So what has been given to you now, where 2 speeds have been given to me. So V1 I know is 40 and V2 is, how do we know it's a speed? Kilometers per hour is always speed, or meters per second. Distance upon time. Distance upon time is always speed. Same like previous, going from A to B and then B to A. So that is the distance D only. This also same distance, it is coming back. So same assume, you have to assume this is suppose for time T1. This is for time T2. From here to here it is taking time T2. Why different time? I told you. You must be riding slow here. You must be riding fast here. We don't know. Now, in terms of shortcut, this is for suppose 1 mark question. Directly, if you remember the formula, it's easy to calculate. Okay, first we'll just calculate what is average velocity. Average velocity is same like this, coming back to the same position. So d minus t, that is total displacement upon total time. So that will be d minus d upon t1 plus t2. So 0. Average velocity is 0. Remember, if you are coming back to the same position, you have to know your average velocity is 0. There's no thinking on that. Your average speed, okay, 2 ways are there. This is a shortcut way. That's for MCQ you can use, I told you. So which we just now learned. So directly substitute 2 into 40 into 60, 40 plus 60. Okay. So that would be 624, 48. That would be 48 kilometers per hour. Please write the units, otherwise they'll cut marks. Whatever is the unit of this, the same unit will come here. So your average speed shortcut answer, you know that it's 48 kilometer per hour. Now, suppose if it's 3 marks problem or 2 marks, don't do like this shortcut. Follow the long method. Or if your teacher is asking you to follow the same formula, no, you can use, no problem. But they are specifically using the long derivation method, then you cannot use this shortcut. But you know that now, looking at the shortcut, I should be getting this answer. So we'll just confirm this. So average speed by long cut method is nothing but total distance upon total time. So you know that this is d1, d plus d, total distance upon total time t1 plus t2. Now is there time given for me to substitute here? No. v1 and v2 I know. Suppose if we had not known this formula, then how to calculate? t1 and t2 is not given. So whichever I taught you in the previous problem, that formula. Speed is nothing but distance upon time. So time is nothing but distance upon speed. So what will be t1? Distance is how much? D. What is the speed? T1, this side it was 40 kilometers per hour. And here it was 60 kilometers. So this would be upon 40. The same way, time, distance is anyways D. What is the speed for time? That would be 60. And now substitute here and then calculate. Anyone who is not understanding can ask, I can repeat. Average speed will be, why am I doing all this conversion? Because time is not given to me. I have nothing to substitute here to calculate. So that's why I'm writing in time in terms of speed and then substituting. So this will be d plus d and then take out common. Take out d common, same like previous problem, and then calculate. And then you can cross multiply the numbers. D I took out common, 1 by 40. D and D will cancel. Then cross multiply. This will reverse and go up. And now you know it's the same thing. 48, don't forget the unit. So this is how it has to be calculated. Any doubts in this problem, you can ask. Okay. Suppose if you have two equal distances. Means if the word comes, what it means? A man covers half distance at v1 and remaining at v2. Calculate average speed. So whenever you come across like this word, a man covers half distance. Half means the total half part. So it's like the total distance is covered into two equal parts. So while drawing the diagram, I will draw, this is A, this is B, this fellow will be C then. Half distance means, suppose if you are taking from here to here D, Then from here to here also will be d. It's equal distance. Otherwise, if you are taking the whole thing as d, then d by 2 and d by 2. But that will simply complicate things. So we will assume from here to here if it is d, and from here to here also it will be d. Why? Half. Total will be 2d. The half of 2 is 1. It's like 1d and 1. And from here to here it is v1. And here to here it is, this will be t1 and this will be t2. What all you need in the problems? D, V and T. Distance, speed and time. So in the diagram, all these three things you mentioned: distance, speed and time. So let us calculate the average velocity. So the main idea was, whenever there's half distance, you draw a diagram like this. It means there are two equal distance. Average speed, same like previous one, and it will follow. Your speed and displacement will be same because it's not coming back to the same point. Same like previous. What is given in the question? V1 and V2. But this is in terms of time. So I'll have to convert it. So this is what? Time is nothing but distance upon speed. So this will be d upon V1. Same thing. Same as previous problem. We just copy paste again and do the same calculations again. Then this and cross multiply. The overall answer will be now suppose if you have three equal distances. Okay, so different distances will have different speeds. So what we'll assume, first one would be V1, V2 and V3. So that way this will be A to B and B to C and then C to D. Three equal distances. This will be D. This also will be D. This also will be. Will give different velocities, V1, V2, V3. This is traveling at time T1, time T2. This is time T3. Everywhere distance, speed and time you have to mention. Only distance remains the same everywhere. Velocity and time are different because we don't know at what speed the person means, so how much time it took. Not necessary from A to B, whatever time he takes, he has to take here. It could be different. So here also you may follow different speed, here different, here different. So don't write single V everywhere. Mention 1, 2 and 3. So average speed would be total distance total time. So this will be D plus D plus D. Total time will be T1 again. Over here also velocities will be given. I want the answers in terms of velocities. So convert that. So you know that speed is distance upon time. So time will go up, speed will come down. Sorry, speed. So if you are using T1 here, V is, and then D is same for everyone. The same way T2 will be D upon V2 and T3 will be D upon V3. Now put all the values here. Instead of T1 put this and this. Mostly problems are asked from this chapter. There is no need of breaking ahead too much on the theory. If you are understanding these problems, enough. So total average speed will be this will be 3D, D plus D plus D, and instead of this, now take out D common from all this terms. So 1 upon V1, 1 upon V2, 1 upon V3. Now there are three things. So simply don't cross multiply. So we will take LCM of all the three. LCM means always you have to multiply the three numbers or the denominator. So V1, V2, V3. Same thing you have to multiply common. So what is the LCM? If there were like three different numbers, no, 1 by 3, 1 by 2 and 1 by 5. We have to take suppose average of this. Normally some of them they do the long method. First they cross multiply this and then this. But LCM method I will teach. We always take the denominators 3, 2 and 5. And we start finding the common ones. If nothing is there, so 2 and then 5 like this. And then we multiply all the three numbers, no? 5 2s are 10, 10 3s are 30. So 30 becomes a LCM. So same way now if we have V1, V2, V3, that becomes a LCM. And then we have to multiply every term by that. V1, V2, V3 upon V1, V1, V2, and then the third one also. And then the common one. So this is all from your 10th standard. Multiply all the terms by the common LCM and one common here down. What is going to happen? This will cancel. This will cancel. D also will cancel. And this fellow will become ulta and go up. This will be our answer. Three times V1 plus V2 V3 upon this. Both somewhere I've kept the same letters. Wait, on there V3 it was. Just correct this. You want, you can rearrange the letters. 3 V1 V2 V3. So this is the average speed.
Miss V2.
Yeah, here it is correct. I just arrange it. Otherwise, you can keep the answer like this. I just wrote the last term first. 1 and 2, then 2 and 3, then 1 and 3. This is also correct. Let's stop here. Continue with the problem in the next class.